Welcome
All right.
to the YouTube channel.
So what?
Welcome to the YouTube channel.
Welcome to the YouTube channel. You're about to learn, prepare. All right, here we go. This is part 2 from yesterday. Same thing, factorial, combination, permutation. Okay. So I want to just break it down real quick, and I put all the notes on the right side, and I'm going to talk about that in a sec. But when we're looking for factorials, like we did here, that's just the number of options. Okay. So if I have these 3 glow-in-the-dark balls. Right. Ooh, look at that.
Wow.
If I could pass them out to students, right? Let's say I have 3 students, and I could pass it out to them. The ways that I could pass it out to them is going to be factorial of 3. Because I could first pass this one to TK, I could pass this to Jordan, and pass this to Alejandro. Or I could pass this to Alejandro, pass this to Jordan, then pass it to TK. And then they could pass them all back to me, and I could pass them all back at the same time. Ready?
You're supposed to do it at the same time?
Oh. Fail.
We sound like the Wii, you know?
So, that's great. So when we're talking about the factorials, that's just the number of options. If you can order 10 things off of the menu at Cheesecake Factory, you could order the first thing, and then the second thing, and then the 10th thing. It would be factorial of 10. That's the number of options that you could pick as far as just in general how you're going to, what order and all that you're going to pick. Okay. Now when we get to finding the number of ways to arrange those options, then we're talking about combinations or permutations. And this is where I'm going to try to, can I put this on your desk for a sec? So I hope we can see this at home. Maybe I'll close this in a second. All right, so yesterday, by the end of the day, I thought of different ways to teach this using this menu idea. So if my menu is fish, fries, or hamburgers, those are the 3 things on the menu. Okay. To find the number of ways the items can be arranged, I first want to think about, okay, what is a combination? Order doesn't matter. Repeats are okay. So if I end up ordering 2 things, and one's a fish and fries versus fries or fish, that's only counted as one option. Right? Fish or fries or fish, that's just one option because repeats are okay and order doesn't matter. I'm not going to count that as 2 different options. Okay. But when I get to permutation, order does matter and you can't repeat. So here, fish and hamburger versus hamburger and fish, I count those as 2 separate items, 2 separate options. Okay, so basically you want to look to see how many ways we can arrange it, and when we're doing combinations, we're limited. We can't count these as 2 different things. We have to count these 2 things as equal, one option. Permutation, order does matter. So because these are rearranged, we count them as 2 different things. You see how those are slightly different? Okay, so it's about choice and ways to arrange your options here. It's really just like the very, very basic. So, interesting. Ponder that. So then we're back, and let's look at this a little closer now. All right. So we know these formulas are going to be up there. These are going to be accessible to you. We kind of know the generals of which ways to arrange between these 2 things. And this is new. So I need you guys to copy down this part. This is new. And really, these are the main notes here and up here for today. Numbers 1 and 2 questions. These are the 2 questions you're going to ask. We're going to do 2 scenarios that kind of break down how you know if it's a combination versus a permutation. Okay, you got to be able to figure out which is which. So I'll give you just a moment to copy this down. The main question you're asking is, does order matter? Does it matter about the order? Okay, so I'll give you just another 30 seconds for that. While you do that, I'm going to try to juggle. For those at home. Oh, really? Sure can. I got 2.
Oh.
Got 3.
Oh.
That's going to get a couple of subscribers right there. The Juggler Union. Not the Jugglers, that's right. Headline.
I feel like to get more views, you should be naming your titles like crazy things. Yeah,
I like that. I like that.
like math problems gone wrong, gone violent.
Math problems
In the hood.
That gets the views.
Math problems, spaces of death.
The thumbnail has to be like some crazy picture.
You don't like this one? A flip off the desk?
It's gotta be like someone in the hospital. It's like math problems gone wrong.
All my examples are like safety. All right, bring it back. Question, Jordan. Okay, what's your follow-up?
Malik said that like you should wear like a do-rag and get like a bunch of fake tattoos.
Right here? It says
Like
math.
math
Math life.
On all your fish math life.
Yeah. Or
Functions like on the side of your
permutation, combination.
On your forehead, put I forgot what I was gonna say.
Jordan.
Equations don't stop.
Equations don't stop.
Yeah.
Can I put it backwards so it's for me to read in the mirror? Oh man. All right, that was fun. Let's bring it back. 2 questions we're going to ask to decide if it's a combination or permutation. This is what we ask. Does order matter? Does order matter? So when I threw the these glow-in-the-dark balls here out, did it matter who I threw it to? Jordan?
Yeah.
TK? Alejandro? Does that matter? All right, I want to try it.
Same time?
Yeah. Not hard.
Oh,
Oh wait, throw it back, throw it back, throw it back.
1, 2, 3.
You was at it.
How not to play soccer goalie. All right, so it didn't matter. Didn't work. Does order matter? Your question.
No.
If order did matter, say if I was picking out a soccer team and I had to pick out my forwards and then my midfielders and then my center back, left back, right back, those are aspects where the order does matter. So then I'd say yes, permutation. If it doesn't matter, like throwing out the balls out, then if it's a no, then it's a combination. You have to ask these 2 questions. And sometimes you'll know right off the bat just because this is answered so clearly in the question. It's asked in the question. Okay? So based on that, then I would use my combination or my permutation formulas here to figure out how many ways we can arrange it. Okay? Second question. Can there be repeats? If yes, then combination. If no, then you have permutation. So let's see. I'll give out a couple examples here. Oh, let's just do example 1. You guys want a minute to write down example 1 and 2 real quick?
Yeah.
Yeah? Okay. I'll pause it. Back to my juggling. Have action. Good. All right, example 1, and we're going to ask our 2 questions to figure out which one we're dealing with. Find the number of ways to match your 5 terms with 4 categories. So here are our terms and our category. Are we going to have a term, or excuse me, are all my terms going to match with 1 category? No. Okay. Right. So now I'm not going to use all my terms, but I do have 1, 2, 3, 4, 5 options here. That's my total. Think of the menu, right? These are the items on the menu. The number of items on the menu here, we have 5. The number of desired outcomes or things you're going to order, here's what you're going to match. So redwood goes with what? Yeah. Tree, tuna? Fish. Apple. Whoopsie. Redwood spider, you ever heard that? Good. Fly? All right, turtles left alone. Oh. So let's ask our questions. Looking at this right here, actually I want you to think about it for a moment and ask first, does the order matter? Did it matter how I linked those up? So think about that for a sec. Talk to your neighbor.
Yes.
I heard that.
All right. Okay. Who spoke with their neighbor and has a pretty good idea? Does the order matter?
Yes.
Jordan, what do you think?
Yes.
Well, why would you say the order matters?
Yes.
Use your favorite word, yes.
No.
Okay. Your partner maybe want to elaborate why order does or does not matter in this
Yes.
case? Yes.
It does matter
Because?
because you can't put redwood with fish.
Right. Right. The order of how I link these, it does matter because there is a correct answer with it. If I link redwood and fish, tuna and fruit, that's not going to work out. So yes, we'll say order does matter. Real quick then, can there be repeats? Think about what that's asking in this context. Just 5 seconds, talk with your neighbor, and can you have repeats? Talk with your neighbor, 5 seconds. What do you think? I'm gonna pretend that you could have repeats, and it would be the weirdest way to answer the question all time. So if repeats were possible, then I would say I think redwood is a tree, and a turtle is also a tree, and tuna is an insect, and apple is a fish.
Whoa, apple
Masterpiece. That's Picasso right there.
Picasso. What have I done? I've done a repeat here because I've said redwood and turtle both have the option of being a tree. That would be saying I could repeat the answer for multiple options.
So the fly would have to be a fruit.
The fly would have to be a fruit.
Fruit fly. Yeah. Makes sense.
That's a joke of the day right there. All right, at the end of the day, I'm making that hilarious. So the reason why, in this case, no, we cannot have repeats is because I cannot connect redwood and turtle. Just like if I was assigning people on a soccer field, if I say, hey, Michaela, I need you to play striker and goalie. Is that okay? You can do it? You're like Jorge Campos, you come out. On a football table.
Oh, yeah.
Right.
Dang it. Wow.
You ruined it. Just, you did good. You did ruin it. All right, so you see how some situations it's going to be a little more obvious. In answering these two questions, one might be more obvious than the other. So once we figured this out, we figured it was a what? Let me do this right again. All right. We figured out it's a permutation. So let's take our permutation. All right. Remember from over here, N is the number of items on the menu. How many items are on the menu in this case? How many items are on the menu that we could have matched up?
5.
1, 2, 3, 4, 5. Okay, and how many requested items or final categories could we match with? 4. 4. So let's set it up. 5. Factorial. 5 minus 4 factorial. So what do we end up with? 5 factorial over, what's this?
1.
1 factorial is? 1. So it's 5 factorial. What is that? 5 times 4? Let's do that. 20 times 3? 60 times 2? Times 1? Done. There's 120 ways to arrange that.
Oh, because you're factoring
This?
5.
Factorial is that times that times that times that.
Okay, that's where I messed up on the homework. I
This
forgot we had factorial 5 like
The top.
after. So I just did 5 over 1 and then got 5.
Okay. So now you see what we got to do. Okay. So remember the exclamation point? We're talking factorials. So that's the last bit we got to do. Does this seem pretty straightforward how we chose? We figured out if it's a permutation or combination, and then we do it out. Okay.
Yeah.
Great. Let's do this second example and Set you loose. All right, it's coming over again. It's okay. All right, this is something that maybe other than TK, you know, not many students will have this option. So in this case, if you want to be my TA, you know, think about it.
Yay.
Check it out. Example 2.
What about me?
You're not a junior yet.
No!
In 2 years. All right. Mr. Pasillas has 8 students who are juniors. He needs to pick 2 students to be TAs next year. How many ways to pick his TAs? First off, let's ask our 2 questions. First question.
They have to be awesome.
They have to be awesome. Are they awesome?
Yes.
Does order matter?
No.
Would it matter who I pick with the 2 students? I could pick this person or this person. So order doesn't matter. Can I have repeats?
No.
No.
Yeah.
Because you can't have the same.
What do you think? What's the argument? Because someone's got to reason this out. What's your argument? Blake, what's up?
There can't be repeats, otherwise you have to close someone.
That's
You
what
can't have the same person both
Yeah.
times.
And let's say you can only be my TA once. I think that's generally, there's not a lot of seniors that have a teacher twice. When you're a TA, you only TA 1 period usually. Okay, so could TK TA my first and my 3rd period? No, that's not how the schedules are set up.
It's impossible.
It's impossible. So let's see. Order, does that matter? No. Does, are we allowed to do repeats?
No.
No. So let's see what that matches to. Wait a minute. Okay, we have a problem.
There can be repeats.
There cannot. Does the order matter? Does the order matter? I had this perfect beforehand. Let me pause just for lack of confusion. All right, and we're back. All right, bring it back. What we just figured out. I think that actually it makes it a little tricky when we're thinking of 2 students. Let's look at 3 just for a second here, okay? Let's look at 3. So a good example came up if it was Trinity, Emil, or TK, right? If I have to pick 3 different students, right? And let's say Noah's also in the group that could be my student, TA. I could pick TK and Emil, or I could pick TK and Noah. You see how we could repeat TK in the different combinations I could come up with. So I could repeat, and the order, did it matter who I picked first though? No. So since the order doesn't matter and repeat is yes, we're looking at a combination. This example is probably a little bit harder than what you'll see in the homework class. Okay. So let's do this out real quick. Combination. We have combination. How many students are on my menu? 8. How many requested items? How many TAs? 3. So we're going to go with 8 factorial, and then 8 minus 3 factorial, and 3 factorial. No, you can't. So you could use a Desmos calculator to work this one out. We could do it by hand. Let's just simplify it a bit. Ooh, I know what I'm going to do. Watch this. Okay, everybody watch what I'm going to do here. This is the tricky one. The trick I did before. We have 8 factorial, which is 8 times 7 times 6 times 5 factorial. The top here. 8 times 7 times 6 times 5, it would be times 4 times 3 times 2 times 1, right? 5 times 4 times 3 times 2 times 1 is 5 factorial. So I'm going to leave that there like that. Okay? Because down here I have a 5 factorial and I have a 3 factorial. Now I can cross those guys out. So the reason why I stopped here and said this is just 8 times 7 times 6 times 5 factorial is because I was expressing 8 factorial out. Okay. Now, if I were to do it just purely, and I would go 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, what I'm saying is this part right here, this is 5 factorial. You see? That is 5 factorial. So because I did and just stopped here, now I can cross out my 5 factorial, 5 factorial. Those go into the same values. 8 times 7 is 56, times 5 is 56 times, what? 56 times 6, 336, over 6. Let's see if I can do this. 5, oh yeah, 57. 56. 56, what? Hey, don't worry about that part. If you had on your calculator, work this out, you'd have a big number there. You'd have 2 other numbers, you work it out, you divide it out. All right, I want this to be a little bit of a get you started. I want you to work on those problems in pairs. So find your pair you're going to work with. How are we feeling with this? Thumbs up, sideways, down. We're figuring out if it's a combination or rotation. Okay, you got to just see some more problems, right? You got to see more problems. All right. That's it. Thanks for joining us. 123rd gets some Oreos. Oreo packet, not just one. That's Costco version. I don't have a membership. Sorry.